Hey guys, and welcome to your next tutorial. Today we're going to be doing something really fun. We're going to be playing with making different renderers for our balls. Now right now we only have one renderer. As you'll remember, we created a separate renderer class and a controller class for our balls so that we could separate all that code from our ball class. And it gives us the ability to make all these different kinds of renderers without cluttering up our ball class. It's as easy as just popping in a new renderer and using it. Now right now our renderer class doesn't have everything it needs. Right now, it's just encapsulating a little bit of rendering code for a ball. Instead, it should be pretty self-contained. It should have its shader. You should be able to just pass in everything it needs whenever you call the draw function, and it should be able to handle it without any setup in the main game class. But right now, our main game class is what's controlling the shader, and if we forget to set up the shader right, then our ball renderer isn't going to work correctly, and we'd have to do this for all of our different ball renderers. So let's go ahead and make a few modifications to our ball renderer class. We're going to actually make an interface that we can inherit from to make all sorts of different kinds of ball renderers that we can swap between. You'll notice here I've made a few changes to the way things are being rendered right now. Basically, all I did was made it to where there's a bunch of different random colors and sizes for the balls instead of just hand designing a few. Now, I did say in the previous video we were going to learn the flyweight pattern today, but I think I'm going to actually put that off until the next video because I really wanted to get some new ball renderer stuff while the concept of this separation, this modularity was still fresh in your minds. So let's go ahead and stop this and get started here. And actually, I need to lower the resolution because right now I'm running at a really high res. So we need to go to the init function and let's bring the screen width and height back down to, let's say 1920 by 1080. That should be good. Alright, so let's go to our ball renderer class and get started. Now right now, as you can see, it just renders a ball, but instead we should render a list of balls. We should render all of the balls. So let's go ahead and just pass in vector of balls. So we'll say std vector of ball, and we'll call it balls. Now we need to include vector for this, of course, and that's not what I wanted to do. Include vector with a lowercase I. So now what this is going to do is render all of the balls. Now we also want it to be able to contain its own shader. Each ball renderer should have its own shader. Now you're thinking, well, what if we want to reuse the same shader between different ball renders? Well, we're going to be duplicating shaders. Now that's not actually as big of a problem as you think. Shaders don't take up a lot of VRAM. They're very small, at least these simple shaders are. So it's okay if we duplicate the same shader between ball renders. Now if we wanted to, we could implement some kind of shader cache class that would be able to cache shaders that we could pass into this. But for now, we're just not going to worry about that. We're going to go ahead and duplicate shaders as we need. Now since we're going to make this an interface, let's make this a virtual void render balls so that we can inherit from this. And let's also have a protected variable since we want to be able to share it. And this is going to be our shader. So let's include Benjin shader or Benjin GLSL program. And let's create one of those. And we'll just call it pimp program. And we're going to initialize this to null pointer. Now, what we could do, oh, and this needs to be a pointer. Now what we could do is we could make an initialize function, an init function or a constructor that sets up this GLSL program. Now I wouldn't recommend using a constructor because if your ball renderer class gets created before OpenGL is initialized, then your program isn't going to get set up correctly. Now we could use the init function and manually initialize it, but there's an even better thing we can do. We can use what's called lazy initialization to only initialize this GLSL program whenever we need it, and that will happen in the render balls function. It's kind of weird, but you'll see it's actually a really helpful thing. So let's go ahead and copy this into the CPP file, which is, if you press Control-KO, that's a hotkey that'll take you to the CPP file in Visual Studio. So I'm just going to put it here and just replace the one we have, and we don't actually need the virtual keyword in the CPP file. Alright, so what we're going to do is instead of rendering a single ball, we're going to loop through all the balls, but first we need to check and see if we need to initialize our GLSL program. So we're going to say if mProgram is equal to null pointer, this is where we initialize it. Now this is the concept called lazy initialization. It's called lazy because you only initialize it once you need it. If we never call render balls with our ball renderer, then we're never going to even allocate the program, and we're going to actually save resources that way. Lazily initialize the program. So now we just need to set up our program, and let's see, we're going to need to allocate it. So what we could do is we could use new to allocate the program, but instead we're going to be good C++ programmers, and we're going to use a unique pointer. So let's go ahead and include memory here, include memory, and we're going to change this into an std unique pointer, GLSL program like that. Now in order to properly destroy this, we need to make sure that there is a destructor in the BallRenderer class. So we're going to say BallRenderer like this. This is one thing you have to do for unique pointers, and we're going to put this in the CPP file here. And it's okay if it has no code in it, empty. As long as we are including GL program here, it'll be fine. And actually, we don't actually need that simply because we are including the GLSL program in the header file. If we had used a forward declaration instead, then we would need the destructor. But since we're including it in the header file, we actually don't need the destructor, so we're good. Alright, so now if we want to initialize the program here, we just say mProgram equals std make unique. Make unique. There we go. And the type we're going to make is a Benjin GLSL program. And the parameters it takes are nothing. It doesn't have any parameters, so that will allocate it. Next, we need to compile shaders. So we'll say mProgram, compile shaders, and we're going to do shaders, and we'll do the one we always use, texture shading.vert, and we'll do shaders texture shading.frag. That should load those shaders for us. Now we need to add some attributes. We'll say add attribute, and let's see, I forgot what they were. Let's go into main game and we can just grab them. Here, I'll just copy all this so we don't have to manually type it all out. There we go, and I'll just put in program for all this. Alright, so that's all we have to do. This will lazily, and this should actually be an arrow for all of these. So this will lazily initialize our program. As soon as we call render balls with a program that is null, it will allocate a new one. So now we need to use our program, and let's also remember to unuse it. In program unuse. And now in here is where we're going to upload uniforms, and we also need to loop through all of our balls. So the first uniform we need to upload is the texture uniform. And that's going to be pretty much the same as it was before, so we're just going to go ahead and copy that. Let's go into main game. And we need to go to the draw function, which is down here at the bottom somewhere. And here we go. I'm just going to copy this whole block right here so we can use that in our BallRenderer. So instead of texture program, obviously we're going to use mProgram, and we're going to use an arrow here for getting the uniform locations. Now the only thing that's different here is we can't get the projection matrix from the camera here. We need to actually have it passed in into our render balls function. So we're going to go ahead and do that. At the end here we'll say glm mat4 reference, and let's make it const for safety. And we'll call this projection matrix. And this is getting long, so I'm going to put it on its new line. Let's go ahead and copy this and just put it in the CPP file on its own line. So now we have the projection matrix, and all the uniforms are getting set up correctly. So now we can just loop through all of the balls and render them. So we're going to say auto ball in balls, and we will render them here. So render all the balls. And now let's make sure we're calling this correctly from the main game. So instead of looping through anything here, we're just going to use the BallRenderer to render them. So we're just going to say BallRenderer.render balls. And we will use, let's see, the sprite batch, and then balls, and then projection matrix. So we no longer need to do any of these other uploads here. We do still need to get the matrix, but we don't need to upload them anymore here because that's going to happen in the BallRenderer. However, our heads-up display, I believe, does require it. So let's make sure we do it there. So let's make sure we get all of these uniforms down here. Later we could make a separate renderer for the heads-up display, but for now, since it's just rendering an FPS counter, I'm not super worried about it. That's something you guys could definitely extend later. What is it, Imballs? Imballs, there we go. Now we want to make sure we're no longer using this texture program up here. We actually only want to use it for the heads-up display, so we're going to use it below. And I believe that should be all we have to do for our ball renderer. Oh, of course, we have to actually render the balls. So we're going to do pretty much the same thing we're doing up here. I'm going to copy these three. And actually, that should be all we have to do since we called it ball here. Now let's go ahead and run it and see if it does what we want. Let's see, render ball is not a member of BallRenderer. Right, we no longer have this function in ballrender.cpp. All right, now let's run it. And we get nothing. I did something wrong here. Let's go back to main game. I'll pause the video real quick to see what's wrong. So the bug was pretty simple. All we had to do was make sure that we are keeping our shader bound when we actually call render batch. The issue was in the ball render, we were unusing our program down here before we actually rendered the balls to the screen. Because remember, spritebatch.draw doesn't actually draw anything to the screen. It just prepares the glyphs to be drawn. So we actually need to be calling spritebatch.begin and end inside render balls. Simple as that. So we'll go into main game and we'll just take this out of here. We will remove that, and we will also remove the spritebatch.begin call, and we're going to let our render balls function handle that. So down here at the bottom, before we unuse the program, we end, and after we use the program, we begin here. And instead of spritebatch, it should just be spritebatch. At this point, we could actually even make it so that the ball renderers had their own sprite batch, but I like doing it this way because it allows different renderings to reuse the same sprite batch, which can be a little bit efficient, a little bit more efficient. So now let's run it and see if we get something rendered to the screen. It should look the same as it did before, and indeed it does look the same as it did before. Awesome, we have our basic renderer. But we have an interface now. So now we can actually define new ball renderers that follow this right here. And I made that public when I was debugging. Now what we also should do is we should make this const here. And if we don't do that, then we could accidentally change balls, and we definitely don't want to be doing that in our renderer. So now let's define another renderer that inherits from BallRenderer. Now we could make a whole nother file, and I would recommend that you probably do make a new file for each of your different renderers, but for now I'm just going to use the same file. So let's make a new class, and let's think. What can we do that's going to be really cool? Let's try to visualize momentum. When balls have more momentum, let's make them brighter. So we're going to say momentum BallRenderer public BallRenderer. Here we go. And we need to make sure we inherit this virtual void function right here. So we're going to say public, and we'll just copy this over. And we need to put override here. That's a new C++ 11 keyword. If you put override here, then that's going to specify that you are overriding a base class function. And that'll prevent you from having bugs later if you ever change this signature up here. And we don't need any private or protected variables. We're just going to reuse this in program right here. Now, as for what we're going to do in the C++ file, I'm going to go ahead and just copy this whole thing and pretty much reuse the same exact thing, but just change how we render it. So we'll change this to momentum ball renderer. And now, instead of rendering with ball.color down here, what I'm going to do is use a different value. So let's think. We want to render with momentum, and momentum is the velocity times the mass. So let's try to make a new color value based on that. Let's make a new color. We'll say Benjin color RGBA8, and we'll say color. And let's make a float color val. This will be the value of our color. And what we're going to do is we're going to use the length. We'll say GLM length of the velocity, so ball.velocity. That is basically going to be the magnitude of the velocity, or it is the magnitude of the velocity, and we'll multiply that by the ball.mass, and that's going to be our momentum. Now we want to make sure this is clamped between 0 and 255. Let's actually make this we'll make it a a unsigned char, since our color RGB8 struct here uses GLU bytes, so we'll make it a GLU byte. So let's go ahead and cast this to a GLU byte. Because remember, color values are between 0 and 255. Now we need to clamp this from 0 to 255. I'm going to use a function called glm clamp, and that will take a number and clamp it between two other numbers. So we'll say glm clamp, and we're going to clamp the momentum between 0 and 255, like that. And let's see, the problem is this needs to be a float. Got to make sure the types all match. And there we go. So now we are clamping it. And we have our color value. Now let's go ahead and set the color value. We're going to say color.r equals color val. Color.g equals color val. Color.b equals color val. And let's also do, why not? We'll do color.a equals color val as well. We'll make it more transparent whenever it doesn't have as much momentum. Now, right now in the main game, I've done a few changes that I actually didn't show you here in the beginning. If we go to Init Balls, I'm actually multiplying. I reduced the initial velocity here. I made it 0.5. Let's let it be the normal velocity that we originally specified. And then here you'll see this is where I make all the random balls. I just have another for loop at the end here that makes a bunch of different balls using random values. I have these R1 and R2 variables here, random values for ball types. There we go. All right, so now let's run it. Of course, we have to use our momentum ball renderer, so let's go ahead and do that. For simplicity, let's actually make a way for us to switch between different ball renderers. Let's have a vector of ball renderers that we can use. We're going to say std vector of ball renderer. We'll use polymorphism here. Renderer star m ball renderers. And anytime we want to add a new ball renderer, we'll just add it onto this vector here. And let's actually make it a, we can do a vector of pointers or we can do a vector of unique pointers. Let's be cool and make it a vector of unique pointers. So std unique pointer. As ugly as this looks, it makes it a lot safer. Ball renderers, there we go. And so now we don't need this ball renderer right here. Instead, what we do is once we initialize our game, we're going to initialize all the renderers. So let's actually make another function, void init renderers. And we'll implement this below the init function. Here we go, init void main game init renderers. There we go, and actually I don't think we can do a vector of unique pointers. I think it's going to give us an error if we try to do that. So for now, I'm just going to use a vector of ball renderers star, just regular old C++ or C pointers. And we'll just remember to destroy all of those. So we'll do that in the destructor here. Let's just make sure for int I equals 0, I is less than m ball renderers dot size I plus plus, and we could use it for each delete m ball renderers I. There we go. I always like to do the delete before I even do the new, so I know I'm not having a memory leak. Alright, so now let's add all the renderers we need. We'll say m ball renderers dot push back, and let's make a new regular ball renderer. We'll say ball renderer. And let's do also a momentum ball renderer. So we have both kinds. Momentum ball renderer. Now let's go to where we get input. I believe we have an input function down here somewhere. Process input. So in here, whenever we get a key down, we're going to check and see if we are pressing, let's see, what would be a good key? We'll just use the number 1 key. The 1 key will change which renderer we are using. So we'll say if m input manager dot is key pressed, and we'll do SDLK 1. That will change to a new render. So let's keep track of which renderer we are using. So we'll have int m current renderer, and we'll start that out at 0. And each time we press 1, we'll say m renderer plus plus current render plus plus. And if m current render is greater than, let's see, m, or what is it, m renders, ball renders dot size. Actually, if it is greater than or equal to, then we're going to loop back around to 0. So we'll just kind of cycle through this. We'll say m current render equals 0. So that'll let us switch between all of our different renders. And now all we got to do is here, instead of m ball render dot render balls, we say m ball renders m current render arrow render balls. Like that. And there we go. So now we can switch between the different renders. Before I forget, there is a bug that we have that I don't think I showed you. If we go to, let's see, ballcontroller.cpp, we want to make sure we fix this bug because it's actually a pretty severe bug. Let's see. It happens when we are, I believe, getting a cell. I'm blind. No, it doesn't happen here. It happens in the grid. If we go to the grid.cpp, once we go to, where is it? Get cell here. This is actually supposed to be a -1 here. If we don't have a -1, you're actually going to have a pretty bad bug. If you have a bunch of compression of balls in the lower right-hand corner, it'll cause one of them to pop out of the grid, and then you'll have a violation error here that's going to be pretty bad. All right, now let's try out our renders. Actually, we can't try it out yet because we didn't. Oh, and we have a null access violation here. Current render because we never called init renders. So let's go ahead and do that. Let's just go call it in the init function at the bottom. We'll call init renders. There we go. And we also need to, in our actual momentum render, we need to use this color value. So all I'm going to do here is replace ball.color with color, which is our rendering of momentum. And let's see what happens here. Alright, so this is the regular render. Now I'm going to switch over to the momentum render. And everything is black because there is no momentum. Now when I click and drag, you can see momentum when I'm throwing things, but there's not enough. So let's go ahead and multiply this by 12. Like that. Now we can run it again. Alright, let's switch to momentum. And there we go. That looks pretty cool. Oh, I need to move it so it's centered. As you can see, as I drag around balls, they collide with each other, and as they accumulate momentum, they light up. That's pretty neat. Let's give it a cool background. Let's change the background color for this. In the momentum ball render, let's see, ballrender.cpp, let's change it so that, let's do GL clear color. Let's change the background color to some kind of weird bluish color. We'll do 0.0f, 0.1f, and 0.5f, and then 1.0f. So this, as you know, GL clear color will change the color of the background. And let's also add this to the regular ball render so that we, once we switch back to the normal ball render, it will switch back to a black background. So let's run it again. There we go, and I'm going to switch to momentum. So now we have a blue background with white balls. That's pretty neat. Let's think of something even cooler. What else can we do? What's another awesome renderer we can make? Well, let's see. How about we visualize the direction of velocity, and how about we also visualize the position? So we'll call this velocity render, velocity ball render. Let's create one of those. Velocity ball render, public ball render, there we go. And we're going to implement this. I'm going to use Visual Assist because I'm lazy. There we go. And I'm just going to copy this whole thing yet again. Now, since a lot of this code is reusable, we could probably separate this into different functions if we wanted to, so that we're not copy-pasting all this crap. Alright, so now, let's see. Let's change the way we do this color value here. Now, instead of using the momentum, we're just going to use the velocity, and we're going to visualize that as color. But how about, let's do something kind of interesting. Let's not visualize velocity in every direction. Let's only visualize velocity in the x direction. So let's create a new color value here. We're going to do, let's say, ball.velocity.x. So we don't need length anymore. And we're not going to multiply by mass. We'll just multiply by, let's make a multiplier, float mult. And I'm going to set this at, we'll say equals 100 for now. And we'll just multiply the velocity by this multiplier. And then we're going to clamp it between 0 and 255 again and assign it to this color value. And now let's also use the position in this one. So in order to get the position, we're going to need to know the window dimensions. And right now there isn't a good way for us to pass that in since our original ball renderer up here, our function that we are inheriting from, doesn't have any parameters for that. But what we could do is apply a special case to our velocity ball renderer that allows us to specify the window dimensions, and we'll do that in a constructor. So we'll say velocity ball renderer here, and this will allow us to pass in some unique things that the other ball renderers wouldn't necessarily need. And for this, we're going to be passing in int screen width and int screen height, so we can visualize position with color, which will look really cool. And we'll make it a private variable. We'll have int m screen width and int m screen height. And I'll use Visual Assist to create it, but it put it in the wrong place, so I'm going to put it right above that. So here we'll just use an initialization list, m screen width for screen width, and m screen height for screen height. And this will be empty. Okay, so now we have screen width and screen height for our velocity ball renderer, excuse me. So let's do some cool stuff. Let's visualize, we'll say for the green we'll do x position. So instead of color val here, we're going to do ball.position.x divided by, we'll say m screen width. And since that's going to bring us a number between 0 and 1, we'll multiply that by 255. And then we're going to cast this whole thing to a GLU byte so that the compiler doesn't complain at us. Now let's do something similar for blue, except let's use the Y position. And we'll go between m screen height. And again, we multiply by 255 and cast. For alpha, let's use that x value here, this x velocity. We'll just use color value. And for R, let's just make R, I don't know, 128 for now. Now let's go ahead and allocate ourselves a velocity ball renderer in our main game. Let's see, where are we going to do that? That is in init renderers, which is right here. So m ball renderers dot pushback, new velocity ball renderer, and of course this takes screen width and screen height, so we'll do that here, m screen width and m screen height. Alright, so now we should also be able to visualize velocity, but only the x component of velocity. I think it's going to look cool. Let's see. Alright, so now if I press 1, here is momentum, or actually this is velocity, and this, what's happening here? It's, oh, I'm using the wrong key down here. Is key pressed is not working correctly. I'm going to pause the video. This actually looks like a pretty severe bug. So the reason that bug was happening is I never actually updated the input manager. Always got to remember to do that, or it's not going to be able to tell whenever a key is pressed, because it requires the previous key state for that, which gets handled in the update function. So update input manager. Can't believe I forgot that. Input manager dot update, and that will fix that issue. For some reason, it seemed to work fine for everything else. Now, what else do we want to do? We want to make a different background color for velocity ball renderer. Let's make the background just black again. I kind of liked the black background. Alright, now let's run it and see what it looks like. Okay, so here is regular ball rendering, here is momentum rendering, and here is X velocity rendering. Now that looks cool. Oh, I did it again. Got to show y'all a full view here. That is pretty awesome, don't you think? So as you can see, we can switch between renders at ease. There's no lag or loading in between anything. This is the importance of having all of your code separated into different classes like this. Since we separated the functionality for rendering into its own class, we can make as many different renders as we want. We can share them with each other. We can do all sorts of cool things. So what I want you guys to do is implement this, and I want you to make your own renders and post the code in the description. You can make a little paste bin post of it. And please conform to the interface here, this class BallRenderer interface. All you need to do is implement one of the render ball functions, or implement a render balls function in your renderer, and post this for us. Maybe give us a screenshot of it. I would be happy to put my favorite ones in the description for this video. I think y'all are going to have a lot of fun with this, and you'll probably come up with way cooler stuff than I can. Also, one thing I want to mention that I meant to mention about performance, and actually, no, I'll just go ahead and do it in the next video. So thanks for watching, guys. Make some cool renders and post them in the description, or post them in the comments. See you guys. Hey, so I just wanted to show you guys a cool render that I made after having a little inspiration. So yeah, hopefully you will see this and it'll give you some ideas on what you can do that is even cooler. This is the trippy ball render. And yeah, so download the source in the description and you'll be able to see how this works, and maybe you'll be able to make it even cooler. I'm sure you guys can come up with way better stuff than this. So, yep, thanks for watching, guys. See you next time.